Okay, so we are talking today about graphing cosecant and secant, which I need you to, I'll often tell you guys this, I need you to not panic. You're going to look at a graph. It's going to look terrible, but it's actually not super hard to graph. Okay? Your mom gets more. So it's only February. Okay, so let's see. Desmos. So that's a graph of cosecant. Okay, so cosecant, very, very interesting. If you wanted to graph cosecant, well, let me back up. In Desmos lets you just type it in. Like I just typed in cosecant of x and it graphs for me. We do not have cosecant on our calculators. No big deal. If you wanted to graph this on your calculator, you would have to graph 1 over sine because that is what cosecant is. It's 1 divided by sine. To graph 1 divided by sine x. Do you need to? You do not need to. So I would like you to see that this guy has repeated pattern. What does it look like the period is? Yeah. Okay, so like I see, like you totally go, oh, it's pi because there's one thing, but
half a pi.
What about this guy? This is part of the pattern, but he's not in the same place. So what's
pi?
No.
2 pi.
It's 2 pi. It's 2 pi because 2 pi gets you that full cycle of the U shape and the N shape. So on page 5, I do not remember if we did it in 6th hour, but I don't remember if we wrote down the period. Do we write down the periods of those? Okay. So the period of that is 2 pi. Now it looks like this is going to be terrible to graph, but look, here's the connection. Let me graph sine for you on the same graph. So what do you notice about the relationship between sine and cosecant? Yeah, like they meet at that 1, right? The maximum of sine is the minimum of cosecant. Okay. What do you notice about, there's a whole lot of vertical asymptotes here, right? There's vertical asymptote here, there's one here. It's at every whole pi value that we've got. What's true about those vertical asymptotes? What happens of, yeah, it's the x-intercepts of sine. So very much related to, cosecant is very much related to sine, which makes sense because cosecant comes from sine. So the key to graphing cosecant is being able to graph sine and cosine. Okay, so you've been doing that, so it's not like it's going to be anything new. Let me show you secant and cosine a second before I get rid of Desmos. So secant, okay, looks similar to the other one. He's just shifted a little bit. Same period is 2 pi, right? It takes a whole 2 pi to get a full cycle. And then here's cosine. So same relationship. Okay, those vertical asymptotes are going to occur at the x-intercepts of cosine. And the maximums and minimums will meet each other. Okay, so the way that we turn that into graphing secant and cosecant, a few more steps, but not difficult. So this is lesson 4.6. And we are graphing secant and cosecant. So, for example, if we had to graph y equals, let's graph cosecant, because once you know how to do this once, then you're going to know how to do the rest of them. So, couple more steps. Its period is 2 pi. So, basically what we do is we graph the dots for sine x. So if we're graphing cosecant, secant is 1 over sine. And we are going to graph the dots for sine x. I would not, unless you really want to, I would not put that full graph in for sine. Okay. Sine goes from 1 to -1. It goes from 0 to 2 pi. So we know sine goes here. Okay, so there are my dots. You can't see them very well because 3 of them are in the line. Now, we use the relationship between cosecant, what we just saw on our graph, between cosecant and this guy, sine, to, I just lost what I want to say, sorry. We use this to draw in, the next step is to draw in the vertical asymptotes. Okay, vertical asymptotes, this is what Eli said. Vertical asymptotes happen where sine crosses the x-axis. So we're going to have a vertical asymptote here, which is made them a different color so you can see them. You're going to have a vertical asymptote here, and you're going to have a vertical asymptote here. And the reason that happens is because if it happens when sine is 0, we would have a 0 on the bottom of the fraction 1 over sine. So graph the dots for sine so we can make sure that we're putting our vertical asymptotes in the right place. And then we use these dots to be the maximum and minimum of our cosecant graph. Okay, so this guy, cosecant, he comes down and touches here. So he has a U-shaped graph first. There we go. Which this is also why you need the vertical asymptotes, because it gives you the guidelines for where this guy goes. And this guy is the end shape. So it's not any harder to graph. You still need those 5 points. It's just you have to put in the vertical asymptotes and then realizing that you're drawing a U and an N instead of the wavy curve that we've been doing. It's not any more difficult. I guess I already said that. Okay, so let's graph a straight secant graph. Okay, his period is also 2 pi. And it's the same process, except to start, you graph the dots for cosine x. Then you do the vertical asymptotes, and then you draw your graph. He's a little bit different, though, graph shaped. You're going to feel a little bit incomplete, potentially. I think probably my hardest thing to remember is to make the 1 and the -1 actually close to the x-axis, because my graph's going to go up from there. So don't make your 1 and your -1 way at the top. So cosine starts at the top. Okay, so vertical asymptotes happen where cosine is equal to 0, where it crosses the x-axis. I'm going fast. I'll slow down a little bit so you can catch up. Yep, 1 over cosine. Secant is 1 over cosine. So the difference on this one, like you get a whole N-shaped graph here in this middle section. But this guy, you only get half of your U-shape just because it looks different, right? And the other half of your U-shape is over here. So a whole graph of secant, like you get the whole U, you just don't get it together. You get the right half and get the left half, they're just not touching. It's because it's shifted a little bit. I don't really care. Okay, so that's the basic. We're going to do maybe 2 or 3 ones with transformations. Okay, don't freak out. It's not going to be hard. So let's, because I don't want you to freak out. So let's go 3 cosecant.
Oh, yeah.
Okay, so when we have the transformations in there, the good news is, like, it looks like this could be terrible. So the good news is that where you start with the dots for 3 sine 0.5x plus 1. So that's what you just graph this guy with sine. That's where you put your 5 dots, and then you do step 2 and step 3. So again, the thing is giving yourself enough room, because remembering you're going to be going up and down, not in. So you want to actually make these graphs a little smaller. So start with this. That's B. B is 0.5. So what's this period? So it's 2 pi divided by 0.5. 4 pi. Okay, so it doesn't have to be huge. 4 pi. 2 pi is half. Okay. We do have a vertical shift, up 1. This is another reason that we put the dotted line in, because it's going to help us when we make these asymptotes. And then what's the amplitude? So how high does this get? Because up to 4, yep. So 2, 3, 4. And then down to -3. 1, 1, 1, 2, 3, 4, -3. Ah, you're right. You're right. -2. Crap. Okay. Okay, so then you put your dots on exactly. So you ignore the fact that you're doing cosecant, and you just graph the dots for this guy. So sine starts in the middle, goes to the top, back to the middle, down to the bottom, back to the middle. Now, the difference comes because the vertical asymptote will happen where sine crosses its midline. So remember that this dotted line acts like a new x-axis. All we're doing, all of our things around it, so our vertical asymptotes happen at that same place. That's right. Okay, there's our vertical asymptotes. They should be dotted lines. They're not very dotted there, but they should be dotted lines on the vertical asymptotes. I'm going to draw in your cosecant. Okay, so you've got your U shape. And your N shape. Question? Yep. one more. This will give you a good review from Friday that there were some struggles on. And then I'll give you homework time so that you can ask questions. Let's go -4 secant x divided by 2 plus x divided by 4. This is squiggle. Mistake. -4 secant x over 2 plus x over 4. So when you start looking at, I'll see if I can talk you through this after you've tried it on your homework on Friday or not tried it. Connor.
Sure.
I think that the best place to start is the x-axis, right? So what is your value of b? It is 1/2, correct. So b is always the number that is multiplied by x. And so when it's like this, it's harder because you have to think, okay, this is the same as this. And you guys, honestly, whenever I see something like this, whatever class it's in, it's easier to just move it right outside and be like, that's 1/2. Don't look at it like this. Rewrite it. What? Okay. So,
Why don't we just say okay?
what is our period that we have here?
5.
It's not 5.
Half pi. I'm sleeping. I'm not even looking, bro.
It's not 1/2 pi. It's 4 pi.
I keep forgetting that it's not.
Javon, you okay? 2 divided by 1/2 is 4.
Well, because I remember last time you had something going on with the other fractions were like fading. Oh wait, never mind.
So 4 pi.
I just remember he's
Okay. Now, oh, this should be a pi. I'm sorry. How about that?
Say, I was like, you're supposed to add those though, aren't you?
Well, because it's supposed to be a pi. Okay, now.
That's why I was confused.
I like that. I like that
Sure
excuse.
was why you were confused, Javon.
Okay. What's the maximum minimum for my cosine graph? 4, correct? 4, -4. Okay, now let's deal with this parentheses business. Because leave it for last. It's the hardest. Okay. We need to undistribute a 1/2, which is just dividing. So we're going to take our pi over 4 and we're going to divide by 1/2, which is half what though? Half pi, correct. Okay, so if we divide, I'm going to keep switch flip. So 2 over 1, it's 2 pi over 4, which is pi over 2, 1/2. Okay, so this is 2 pi, this is pi. Pi over 2 is going to be here, but I am moving it to the left. So I got to go the other way. And you want?
Why don't you let the dude do his own business?
Yeah. Okay, this is cosine, secant graphs cosine, and it's an x-axis reflection because there's a negative in the front. I gotta put my regular cosine. Why? Are you all talking? Just be quiet. You, Javon, started this with your distraction out the window. Well, that is because you have better sense. Yes. More self-control. This is really ugly.
It looks kind of wrong.
Yeah, I know. So why we were drawing pencil, not pen. There you go. Oh, poop.
Yeah, that's.
Yeah, that's now it's not.
Okay.
Oh yeah.
I forgot that I'm actually drawing cosecant. Or secant. There we go. So it's not the end of the world if you accidentally put your cosine in there. Just try to put him dotted line. There's a lot going on in this graph. Okay, so you guys, short and easy. Well, short homework assignment.
Took the word easy out of that. I don't like that.
Well,
I'd rather be long.
long and easy.
I'd rather be long.
19.
If there's a page out there,
I'm quite sure.
nah, it ain't no book problem. She just wrote that out.
No, it is book problems. 25,
Would you grab
26.
me one?
Yeah.
There you go.
Thank you.
You guys, I would use a whole front side of the paper for this. Don't be afraid to use your paper. It's only 4 questions.
Oh, sweet. Let's go.
When you look at number 19, yep. Not need you to do any more than that. Okay, so number 19 says this. That looks a little ambiguous. There's no parentheses. Okay. If I was writing this, I would put the parentheses there for you to help isolate what is B and what is not B. Okay, that's the only one that has anything that I think could be objectionable. Okay. This is a good time to ask questions if you have them. So please don't just sit and be like, oh, what am I doing?